So 40 is time to start. So thank you, everyone, for joining me today. So the talk is going to be about building your Kubernetes AI assistant with Argo Events, because every talk gets a bit more interesting when we put AI in it. Well, in mine, there will be a LLM component to it, but the idea is really to introduce you to multiple concepts and patterns. So one of them will be Argo Events. So who is already familiar with Argo Events? A couple of you, OK. And so why this talk in the first place? Well, all of us have been working with infrastructure as code now for over a decade, with probably all the good stuff and the bad stuff as well. So fundamentally, what are the challenges of infrastructure as code? Well, first off, it's not really code, right? It's declarative, which can be a good thing and a bad thing. So mainly for infrastructure, that's infra part. But on the coding aspect, so who is a developer here? A couple of you guys, that's cool. So you're also probably familiar with GitOps actions and CI tools. We started with more like Makefile, scripts. We went through the pain of Groovy and also declarative approach with YAML. So again, YAML, everything is declarative. So same sort of issues, right? It's hard to put code in that. And at the same time, with the advance of LLM, large language model, we would like to consume all this infrastructure as code, all this YAML, to both consume and produce them using some sort of intelligence. And fundamentally, start to build, have multiple building blocks and creating Legos. But the problem of all these tools is that they are, for most of them, they are synchronous. Like you want to run Terraform, it's a CLI. You want to run GitHub Actions, well, you run it into GitHub via peer, merge, whatever. So everything is kind of sequential. So the moment you want to automate a bit of infra, a bit of dev, building images, it's very difficult to keep track of everything in a centralized manner. And it's also difficult to scale, right? Because by default, it's synchronous, it's blocking. So this is where I got this idea of, let's build some cool application, introduce Argo Events, which is an event-driven system, and some sort of orchestration, which we are going to use Tekton as well today. So who's familiar with Tekton? A little bit, some of. Yeah, so not bad, not bad. That's cool. So this whole idea is to combine the idea of infrastructure as code, combined with CI pipelines, put that into an event-driven system so that we can track we have, the property of an event-driven system is that you can trace exactly what's happening. If you have a problem, you know exactly what happens and when. So, of course, and by design, it's asynchronous. So it makes things much more, scalable, and then you can also consume it from different way. You can consume it by using CLI, and today we're going to see a Discord. You can, you can integrate with Prometheus, send alert, react on those alerts. So the possibilities become, almost infinite. And so that's the idea of the talk today: how we can combine all these tools together with some LLM, salt, to make a viable solution. This is a MVP of just me building this to teach you something, and at the same time for me to learn. I've built everything with Rust as well. I've been learning Rust for the last probably 6 months. Very amazing language, but so that's cool. So my name is Nick. I've been working on Kubernetes for the last, I think it's not updated. I would say it's more like 10 years now. I should update this 7 years. Different parts of the Kubernetes ecosystem as product management, engineering, developer relations, all those kind of things. Working on networking, storage, edge security. And my thing is really, I love to code fun apps that leverage some Kubernetes concepts, some development patterns, and go out in the wild to kind of show that, and maybe people can learn from it as well. So currently, I'm a DevRel at ScaleOps, who is a company who is providing resource optimization for compute, memory, CPU for Kubernetes, optimizing this and costs, performance, and stability of the cluster. Other than that, this is my LinkedIn page if you want to connect, or if you're into sport like me, I'm a distance runner. We can also connect on Strava. This is probably where I'm the most active. All right. So what are the problems we are going to try to solve today by using this approach of event-driven system and managing orchestration via Tekton? So first off is, of course, in Kubernetes, there is a lot of YAML. You have a lot of YAML everywhere. And the moment you start, coding, creating repository, if you are using GitHub Actions or anything that is within the repo, you have to duplicate this effort every time. So the idea today is to use a single Tekton pipeline where, regardless of the repo, the only consequence that is, depending on the repo, we will just change the parameters. Single pipeline, but with different parameters, as opposed to copy-pasting the same GitHub Actions and just making things a lot more reusable. Of course, there's also tight coupling between multiple repositories to their own folder for the GitHub Actions. So today, again, the idea is to have a loosely coupled system by using Argo Events, the event-driven system. Also, single interface. So typically, if you want to do some automation on GitHub, of course, there's the GitHub API, which has its own limitation. But typically, it's PR, merge, all those predefined sort of actions. Here again, managed by event system, webhook, and you can do whatever you want. It's really like an automation system that allows you to do pretty much anything you want, just react on event. So the idea is a program publish event, send it to the event system, and as a result, I'm going to do something based on that event, as easy as that. As easy as that. We're going to see with Argo Events, there's a lot of tools we can use so that we don't have to write too much code for that. Difficult orchestration. So of course, we need a way with Tekton to find reusable components that we call tasks and convert them into container. This is what Tekton does. It creates, you define tasks, and then those tasks can be combined together to create a pipeline, and every task is basically a container that runs as a job in Kubernetes. So again, the idea is to have, Kelsey Hightower keeps saying Kubernetes is a platform to build platform. So this is exactly what we are trying to build here. Event-driven system in Kubernetes, pipeline in Kubernetes, everything represented as custom resource, which means that they are first-class citizens within Kubernetes. That's the idea. OK, so the bot itself, the whole project, again, is to propose multiple ways to consume the platform. So whether I'm using Discord via a command, we're going to see like /plan for a manifest, whether I'm just with natural language chatting with the bots through LLM, I can convert this into proper action in the cluster. So basically, we provide different ways to consume our system, including reacting based on Prometheus event, right? So with Prometheus, again, it's just a matter of setting some alerts and sending the event to the event bus. Then I can create a task that will do something based on that event. So again, everything is centralized into this event bus. So of course, the benefits of that is that I can either create dependencies between tasks, but I can also highly parallelize the system. And of course, the idea is to avoid a boilerplate. We're going to keep reusing the same pipeline over and over again. So first, quick introduction on Argo Events. So Argo Events is an event-driven workflow automation framework designed especially for Kubernetes, meaning that, again, it lives as a first-class citizen. We have essentially three main components. We have the event source. You can think about it as the producer of event, right? So the source It's basically, the idea is to create a webhook from things like HTTP endpoint, GitHub, GitLab. It can be things like Kafka, RabbitMQ, or AWS SQS, GCP PubSub. There's a lot of option to act as an event source in Argo Events. So it's really, and they are all represented as long-running pods whose only job is to listen to the outside world. So it's really the interface between the outside world and what we are going to automate within Kubernetes. Then we have the event bus. So if the event source is the ears, then the event bus will be the nervous system. So it's a transport layer that decouple the event producer, in that case, the event source, from the event consumer, which is going to be the sensor I'm going to talk in a minute. So internally, this is where Argo is using NATS. So anyone is familiar with NATS, the project? Yeah, so it's a message queue within Kubernetes, but you don't have to install it, right? It's part, when you install Argo Events, NATS will be deployed as part of that. There are different options. You can use NATS by default, or you can use like an external system such as Kafka, for example. So today we're going to be just using NATS because it's the easiest way to get started with Argo Event. So it's going to provide persistency and at least once delivery guarantees. So again, the idea is because everything is centralized in the event system, regardless if you are using multiple components to automate, Tekton Pipeline, Terraform, Pulumi, anything, if you configure them to publish events, then you can safely track what is happening. And if you need to do like replay what happened, you can safely do it. Everything is centralized again, as opposed to synchronous access or synchronous HTTP calls to your system. Then we have the sensors and trigger. So the event bus is the nervous system, event source represent the ears, and the sensors and triggers would essentially replace the brains and the heads. The hands. So the sensor itself is going to be the brain of the operation. Also, it's another long-running pod that subscribes to one or more events on the event bus. So you have multiple event source, send it to the event bus, then you're going to have one or more sensors and triggers, sensors that are going to listen to those events, and the triggers are basically the hands. They're going to do the action based on what the sensors is consuming, right? So you can do things like fire only when a git push event for the main branch arrives, or you can do more complicated things like fire when either a webhook is called or a / command is triggered as well. So you have this ability to compose your trigger based on more complicated and dependent suite of actions. That's a quick, can you see it? Yeah. Quick example, very simple example of a sensor where you define, so you have the kind, then you define a name, the when. So for example, in that case, the sensor is a list of events the sensors depends on. So you specify the name, which is, in our case, the GitHub push event. And you give here the event source name, which is GitHub, and the event name, which is going to be push, right? Pretty much pretty easy. And then the trigger, which is going to be the what, or the action to take whenever the event is received. This is where you define the template. So in that particular template here, we're going to create, again, like one of the main aspects of Argo, and a typical use case is based on the event source. You can create Kubernetes resources that can be job, that can be other webhooks, or that can be container. So in that case, it's a job. And the trigger is going to be to essentially here run the Alpine container, and just as a CI runner, instead of doing any sort of fancy task, we're just going to print echo CI job triggered by a push. Right? So it's not very complicated. You don't have to write code. So what's the benefit of that compared to just building your own event messaging system, where you would have to code all of that? You would have to use so install NATS and code a program that is able to connect to NATS, publish message, consume message. Here, everything is done for you, meaning that as soon as you create an event source, Argo event is going to create a service in Kubernetes with a port. And now it's going to listen to that service and that port. So when you want, as a developer, to create a task or to send something to Argo event, you just send it to that particular service port. Job done. No code involved, right? And then the logic is going to be for the sensors and triggers to react upon that webhook, right? And then for that, you can either create Kubernetes resources, or if you want, just trigger another webhook that, again, is going to call maybe an API that is sitting within an existing container. So you have multiple options. Either you can create jobs, or you can just create another webhook, calling another API somewhere in your cluster. So you have full flexibility, but at the same time, it's very low code involved. And then now we have also Tekton, which is the second part. So first part, we have this event-driven system. Second part, we have Tekton. So Tekton is a cloud-native solution for building CI/CD systems. And again, when I say cloud-native, it means it runs on Kubernetes, and is configured with Kubernetes custom resource. So there are many, many different components to Tekton. It would take hours to explain everything in detail. So here I've just summarized the main component of Tekton at high level. So the smallest reusable atomic unit in Tekton is called a task. So yeah, it's a unit of work, and the best analogy is you can compare a task as a single well-defined function in a programming language, as easy as that. So internally, a task is simply a sequence of steps, and every step is mapped to a container. So this is what made Tekton Kubernetes native. Every step you define as part of the pipeline is going to be a container, right? So this is truly cloud native. Then we have the pipelines, which is the orchestration layer of Tekton. So if we can compare a task to a function, then the pipeline would be the main function that orchestrates all the calls. So the pipeline defines the structure of the workflows, and it's basically a collection of tasks arranged in a dependency graph. So some tasks will be able to run in parallel, and some other tasks will run in a sequential mode. So in our project, so K8s would be a universal pipeline. It's basically a master workflow that's parameterized differently depending on the repository that we are going to throw at it. And then finally, if we have the tasks, we have the pipelines, and I've told you, okay, you're going to spin up a container for every task. At some point, you may want to do some things like clone the repository, and then another task, build the image. But the build the image need the folder where the repository has been cloned, right? So you need to be able to share information, and more particular, you need to be able to share storage between different tasks or different containers. So this is where the workspace, the notion of workspace come in. So the workspace itself most often is represented as a PVC. So, and then this PVC will be shared between the different tasks. So you can download a repository, and then the next task, typically build the image, will mount that PVC, that volume, and then we'll just use this repository, this code, to build the image from the Docker file, for example. That's the idea of Tekton. So here, again, like the unit would be a task. Here, you will see the definition of the workspace. You need to put in the spec. Then you find steps, and the steps is just a collection of containers. So here we have first one, which is clone repo. You give the image, and you can give a script. So here is just git clone a particular repository. And then the second step, as part of that task, is just list file. So I clone the repository, and I'm just listing the files. So second container is the list files, and just, again, I'm using Alpine. Again, another script where I'm just going to list what is inside that repository. So that's the principle. Again, everything is declarative. You kind of wrap your scripts within this task, and job done. Also, the good thing about Tekton is that all those tasks, there are templates, and there's Tekton Hub. So Tekton Hub is like a marketplace where you will be able to find a lot of tasks that you may be, that may be useful, like a Git clone, all this kind of traditional tasks that anyone may be able to use, right? So it's very useful as well. So we have the tasks. Now this is an example of a pipeline, where here the pipeline is just going to use the tasks that we have defined before. So basically cloning and cloning the repository and then listing what is within that repo. So again, in the spec, you define the workspace, you give it a name, then the tasks. You give, again, the name of the task that you want to use, the reference of that task, and then you specify the definition of the more particular workspace. So, and now the idea is also, how do I trigger that? Because we have the pipeline have tasks, but how can I trigger the pipeline? So there's another custom resource, in that case, which is called a pipeline run. So when you create that particular custom resource and apply it to your cluster, this is just basically the trigger to run your particular pipeline. And same thing with task. For every task, there will be a task run that is created by the pipeline. And the task run is just to tell the task to do what? To run, right? Not very difficult. So this is the example of a pipeline run. Here, we just give it basically the pipeline reference that we want, and again, we specify the workspace. So there's a bit of redundant information here where we always have to specify things again and again. You just have to get used to it, but this is, at the same time, it's a bit, you have to do it once, but once you've done it, then it's reusable as many times as you want, right? So that's the idea for the two main components of our project. So event with Argo CD on the one side, Argo Events on the one side, and Tekton on the other. So this is basically the architecture of K8s. So this is how it's going to work, right? So in the middle here, this is our Argo Event, where we have our NAT event bus in the middle here. We have our event sources that runs as, remember, they run as containers. They listen for events. And then we have our sensors and triggers, which are also long-running pods. And those sensors and triggers are going to send a webhook to the different component. Alternatively, instead of sending webhooks, I could have said, OK, I'm going to create a container for every event. Right? So it would be something very dynamic, but it's not really efficient because this is a long-living system. So all the containers, so the K8s API, the LLM broker, and this is a Tekton pipeline, so it's not really a container. So those two are long-lived pods, right? I could have chosen to spin up those pods from the sensors, but again, it doesn't make a lot of sense because they will just be used for that, then shut down, then back up. And it would take some more time every time to just spin them up and tear them down. So instead of that, the way I've used the sensor is send a webhook to those API. So remember, I told you, we send webhook to the event source. So this is going to be the producer of the event bus, and then we have the consumer. And event consumer send webhook to my pods. So essentially, it's an orchestration of webhooks from the producer side down to the consumer side, right? That's the idea. And now, of course, I need to be able to send intelligent information to the source, right? So for that, again, remember, I told you I want to be able to consume K8s in many different ways, like whether it's a Prometheus alert, I want to be able to send that to K8s, or if it's using the Kubernetes API, because GitOps is based on the Kubernetes API, so I want every time that GitOps is making a new recommendation, I want to notify a message on Discord, for example, right? So I need to be able to use the Kubernetes API as well. And in terms of my bots, I also want to support a CLI. So I have the bot which I can talk, or I can install it on my local computer and just use a CLI. So again, having different ways whatever I choose, I want to be able to manage this event-driven system. So that's the idea of multiplying the way to consume and to produce things. So for that, I've got two adapters. Again, they are written in Rust, but it's not the purpose of the talk today. So I've got an event adapter, which is more like reacting based on something that happens in the cluster from Prometheus or from like another tool that has generated something in the API. So I want to be able to gather that. And from my adapter, I'm going to send those events, clean them, format them with the right JSON format, all this kind of cleaning, and then I just send them to the event source. And then I have all the intelligence of K8s in the API that's going to produce some sort of results. Same thing with Discord, because it's a Discord bot. I need a Discord adapter to satisfy all the Discord API requirements for the integration. And then on the other side, what do I have? Right? So I send the events. So if I want to chat with the bots, I need an LLM. This is the AI part. So the AI part is in the LLM broker, where I'm just using OpenAI APIs to formalize the conversation I have with the bot in a JSON payload that is meaningful for my K8s API. But again, it's via event. So if we go through the flows, I send a message to Discord. Discord goes through the event adapter. Event adapter emits an event for the event source to listen. That particular event source goes to the event bus. I've got the corresponding sensors that goes to the LLM broker that's going to parse my conversation, generate a JSON payload that the API can understand. As part of that, of course, I'm going to emit another message when it's done. Go back to the event source. Event source then is going to publish that message on the bus, and the bus to the sensors. The sensor, then I've got a special sensor for the K8s API to listen to those events. So now I've got the right JSON payload for my K8s API to do the action, right? So this is the whole thing. A bit complicated, but once you have this system in place, you can integrate with pretty much anything you want. In terms of the, 4 minutes, I need to do the demo. So I'm generating all the manifests. This is the last part that may be interesting. So I'm inspecting the GitHub repository, detecting application, analyzing the code base structure to create config maps, secrets, so a bit more intelligence, but again, using the LLM broker for that, right? So now we have AI, so we can put AI at work to generate our manifest, as opposed to creating them ourselves using YTT or whatever, or customize, or yeah. So you can just ask AI to do it, and that's basically it. I'm also introducing like an initial costs for the workload to be deployed, and the initial requests for CPU and memory, just using the GitOps API that is going to determine this for me, right? So it's basically another API I can consume to bootstrap my workload with the initial costs I'm going to think of. But then GitOps, of course, over time is going to arrange that and continuously monitoring and recommending all the right resources for your workloads. OK, so now let's move to the quick demo. Let's mirror. OK. So this is my cluster. So you can see in the Argo event, I have a lot of containers. It's because, again, every source is a pod, and every sensor is also a pod. Right? So I have a lot of stuff here. In terms of my K8s in my bot, I mean, it's more than a bot, but let's call it a bot. It has the Discord adapter running, the event adapter, the API, and the LLM broker. So to do all that stuff, it's not. In terms of coding, I didn't do much. I did do a lot, but I didn't have to code all the event-driven system, which probably have taken me, I don't know, 1 more month. I just reuse component from Kubernetes ecosystem, and happy days. Same thing with Tekton. Tekton is my orchestration system. I didn't create anything in terms of the automation. I just have, if I go to the pipeline, I just have like one pipeline. That's basically it. Of course, I have a lot of tasks, right? But these tasks, again, I did it once in just a matter of reusing them over and over again. OK, that's for the introduction. Now, let's try to make it work. So this is my sample repository, where it's just like a sample Node.js application with a Docker file, and I'm also specifying an HPA here, HPA for scaling, so that GitOps can take that object and convert it into something that is much more intelligent. That's the basic HPA. So the idea now is that I'm going to go to my bot. First, I'm going to use, remember, I want to be able to talk to it, but also to use commands. So I'm going to use the plan command. Please work. I don't have video, so let's cross finger. It's going to work. So the name of the service, which is my repository, the environment, let's call it dev, and that's it. So sending command. So I've got a bug here, so it's going to keep thinking, but normally I should see something. Yeah. So I've got here the development. So the namespace is going to be environment. The resource estimates that I have calculated are those ones. The monthly costs estimate again. And then I have the manifests, if I want to see them here. This is the manifest I would need just to deploy to Kubernetes, right? But our idea is not only to generate that, is to deploy. But to deploy, let's say my new friend, K8s, I think I talked to him more than to my wife for the last couple of weeks, which is a big deploy. This into the dev namespace. Okay. Oh, you shouldn't care about the typo anyway. So deploy this there. Cross finger. Okay, so nothing at the moment. Okay, so it sends something. Let's here track progress. We're going to do into the pipeline. So now the pipeline has been triggered. So this is just the UI of, this is the Tekton UI, right? So I have all this clone repo, detect environment variables, generate the manifest, deploy to Kubernetes, and then send the completion back to Discord. So yeah, so here we can see that the service, we can see the service name and the estimated duration. We have, yeah, to track progress, but it's going to take probably about 1 minute. And in the meantime, we can see what it's doing in the cluster. So if I go to pod again, I'm late. We should see more. You can see here, completed. This is all the jobs that are now running from Tekton to clone, to build the image, and then finally is going to be to deploy the manifest into Kubernetes. So normally I should start to see the namespace here. I have my, not there yet, development. Where are we? So we are here, completed successfully. Status here. So everything is green. I guess it's just a matter of validating the manifest, applying the manifest, deploying the container, and then we're going to send hopefully the completion message to Discord there. Another 5 seconds. And if we go back to Discord, in the notification, now we have the success with the duration, where it's been deployed, the pipeline log, and quickly check, wait, we have the development namespace, we have the 2 pods, and if I go to the service, we have a new service that has been created for that particular workflow, repository, and we also have HPA that has been deployed, resource that has been deployed based on that. And with this, I think I'm pretty much done and also late. So again, thank you for attending this talk. And if you want to connect with me, thank you. Any questions you may want to ask me after that, because I'm a bit late, connect with me or just talk to me in the corridor. Thank you.